The tension between open versus closed models in AI started to occur around 2018. And since then, we have seen a noticeable divergence in performance between state-of-the-art models that are proprietary in comparison to open models, although even this is starting to change now. But what we need to recognize is that this competition between open versus closed models is still underpinning a lot of major breakthroughs that we see in AI today. So let's peel back the layer a little bit to analyze the landscape in detail. We know that the AI industry experienced what's called AI winter around 1974 to 1980 and also between 1978 to mid-2000s. And depending on which chart you look at, the time frame might show differently for when AI winter truly started and ended, but it's really the emergence of deep learning that started to show what neural networks was really capable of once again. And one important characteristic before 2018 was that the AI community had a huge incentive for transparency, meaning even though public attention and funding towards AI dried up, the AI community worked together to make incremental improvements in the architecture. However, we saw one critical shift in AI that completely changed this incentive. As funding and capital started to back innovation of AI, a new era began, which is the closed model era. And now, AI advancements had competing motivations beyond just scientific breakthroughs, but now had shareholders and investors that were motivated by competition and profitability. So a new incentive was created, which is lack of transparency, in the name of AI safety. And that's not to diminish the safety around AI, which is something that I'm personally genuinely concerned about for the next generation, but it certainly is a very convenient excuse to create chasm between open models and closed models as AI advances more and more. And this chasm started to form around 2018 when OpenAI released GPT-1, and GPT-1's capabilities went beyond a simple base model to a more specific use case by using what's called fine-tuning. Essentially, OpenAI demonstrated that by incorporating fine-tuning on top of a pre-trained base model, you can get a significant improvement in performance. And the true inflection point didn't happen until 2022 when we saw OpenAI's complete dominance in mass adoption of closed models with the release of ChatGPT and GPT 3.5. And the gap grew that much further apart from open versus closed models. Let's briefly talk about what makes a model an open model. One important distinction in open models is the difference between open source and open weights. Open source is the most permissive kind where the training data, the source code, and the weights are released for public use, whereas open weights only include the weights of the model. And you will rarely see closed model companies release their training data since the data they use to train the model is likely questionable at the least in terms of how and where they got the data in the first place. And this makes it difficult for open models to compete since closed models don't have to share any details about the data, but some open models, and especially the open source models, need to release them. And we know that having a better and wider dataset gives a huge advantage in performance gain. In any case, open models are typically released on sites like Hugging Face, and they commonly release the base model, which is only the pre-trained model with a large corpus of data, so that people who use the base model can fine-tune it for specific use cases. And when AI companies like Anthropic and OpenAI are cautioning for AI safety, it's really this alignment part that can be misused for harmful behaviors. And again, it's not that this isn't a concern, but it's doubtful that the ulterior motive here is just about AI safety for keeping the models closed. For example, let's start with the GPT-1 model by OpenAI that was released in 2018. Some might consider GPT-1 as an open model since they released a paper outlining their training methods and model architecture, but technically, OpenAI's first model release wasn't an open model after all to start with, since they didn't include the model's weights. And since the release of GPT-1, the company hardened its stance on closed models ever since, with the exception of GPT-2, which was initially released as a closed model for AI safety, but 9 months later, they finally released the open model. However, similar trajectory can be drawn for other companies like Google, DeepMind, Meta, and Anthropic. Although they showed great achievement in AI advancements, they regressed further away from open models to closed models to compete with each other. In other words, the state-of-the-art model became more hush-hush, and the byproduct of that very competition led to the chasm between open and closed models being even greater. Fast forward to March 2023 with the release of GPT-4, we have no idea what training data, training methods, or weights, or even what the architecture looks like for the GPT-4 model, which was a great invention. And the same thing applies for Google's Gemini model and Anthropic's Claude model, and similarly for Google's Lambda. And this by no means is to criticize the capitalistic nature of AI advancement. It would be foolish for me to say that we didn't benefit from companies like OpenAI, Google, Meta, and Anthropic. It's rather an observation of how the industry is shaped, going all the way back to the Turing test in 1950 through AI winters in the 1970s and 90s, and all the great achievements that were made since then, and now the bifurcation of the open and the closed model model is certainly an interesting observation to make. For example, GPT-J and GPT-Neo-X were released in 2021 and 2022 by Eleuther AI, which was grassroots movement to replicate OpenAI's GPT-3 model, but as an open model instead. Bloom model was released with 178 billion parameters by Big Science and Hugging Face in 2022. Mistral was found in Paris in 2023 and released some of the strongest open weights model we have seen. But even with all of that, in comparison to what was happening in the closed models, the gap between open model and closed models started to get bigger and bigger. And not only that, the size of the model seems to get larger each year, and the training data also scaled from billions to trillion tokens, meaning the feasibility for regular contributors to compete with closed models started to make more and more difficult. However, despite the fact that open models always lag behind closed models since its inception, there are two significant events that we need to consider, which are Llama's weights being leaked by Meta and the release of DeepSeek R1. These two events mark the pivotal moment when the performance of open models start to catch up to closed models. Meta's Llama model was leaked in 2023 to the public, and it was a pretty big deal. The 7 billion quantized model required VRAM of 10 gigs, which was relatively feasible for even consumer-grade GPUs to now tinker with the model. And this happy accident gave open models the means to compete with closed models like GPT-3 and many other variants spun off from them, namely Alpaca, Vicuña, Red Pajama, Falcon, Mistral, all of which snowballed into a steep incline as you see from this chart. But there was yet another roadblock that happened around September 2024 when OpenAI released the first reasoning model as a preview, and this created yet another performance gap between closed and open models. OpenAI's O1 surpassed state-of-the-art models on Amy by nearly 20%. And while OpenAI gets a lot of criticism on many fronts, it's really hard to not appreciate how much advancements they are making. First, by using decoder-only model from transformers, then GPT-1 demonstrating the concept of fine-tuning beyond pre-training to take it to the next level, and now the O1 model with reinforcement learning and chain of thought that raised the bar yet again. So yeah, no wonder closed models like OpenAI are able to continue creating gaps in the performance. But this also changed when China surprised the world by releasing the DeepSeek R1 model in January 2025, and the gap between open model and closed model narrowed once again. This was a huge deal that ended up wiping $600 billion in Nvidia's market cap, and the impact was huge where people started to rethink whether we needed that much investment in AI innovation in the first place. DeepSeek proved that state-of-the-art models like O1 can be achieved with lesser hardware, but also with everyone's contribution by making it an open model. And since then, open models have gotten more and more impressive from companies like Qwen, Moonshot, and Zifu, and this has been an exciting time for the open model community. But even with such advancement being made with open models, the world moved on, and Nvidia's market cap and share price not only recovered, but are also at an all-time high still. And since then, the difference between open and closed models have been getting more and more blurry. So as the industry continues with the open versus closed model competing against each other, let's see how this all amounts to, whether we'll see closed models no longer being viable since the upcharge in API usage starts to make less and less sense, or maybe closed models will continue to raise the bar like they've been doing all this time by creating enough margin to pull public's attention towards using their superior services for higher fees.